So this is just a quick walkthrough of a circular motion practice problem. This is from the problem set packet that you guys got, and I'm going to go over how to do question number 2. So we have a 615 kilogram racing car moving with a constant speed, okay, completing one lap in 14 seconds. So that's my period, or the time to complete one loop, and we have a radius of 50 meters. So the first thing we need to find is the acceleration. Remember, we have a specific acceleration for things moving in a circle, the centripetal acceleration. This equation is on your reference table, and it's the idea of the velocity squared over r. But the thing is we don't have the velocity. So if you remember, I told you guys to memorize this equation, that the velocity is 2 pi times the radius, again, that's the circumference, over that period or time to complete one loop. So we would do 2 pi times the radius, which is 50 meters, over 14.3 seconds. And this is going to give us the speed that this thing is moving at. It's moving at a constant speed. So 2 times pi times 50 divided by 14.3. We get a speed of 22, and it's a speed, so we're still in meters a second. So then I take that speed and plug it in here, 22 meters per second squared, over the radius of 50 meters. Okay, so we do 22 squared divided by 50, and we get an acceleration of 9.68 meters per second squared. And the units do work out, even though they don't seem like it. So we have to square the meters and the seconds from the top, then divide by a meter. So one of the meters cancel, and we're left with a meter per second squared. Hooray. So then it says, what force must the track exert on the tires to produce this acceleration? So when you're moving in a circle, remember your net force is really because of a centripetal force, which is caused by some other force. So whenever you have a car going around a circle, it's actually the friction force causing you to move in that circle. So that's what we're going to solve for. But we can solve for it by doing the mass times the centripetal acceleration that we just found. So that's 650 kilograms times 9.68 meters a second squared. So 615 times 9.68 gives me a whopping 5,953.2. It's still a force, so we're still going to do it in newtons. Okay. Now, if we needed to, we could actually use this, since it is a force of friction, specifically static, because the tires are not sliding. We could use this to find the coefficient of friction, okay? Because we could figure out the normal force. So normal force is just going to equal mg, and we could solve for mu. Okay? So if you were thinking like, oh, what would a free body diagram look like on this? So we have this car going around a circular track. Okay? We have an FG pointing down on the car, normal force pointing in, and a force of friction pointing in towards the center. And remember, that force of friction is what's causing our centripetal force, so we can set it equal to MAC. Okay? And that is an example problem going over all of the equations that we covered in the notes.